Hello friends, let's continue with our series. In the lecture number 13, we will be learning about linear regression. Alright, let's begin. So, what is linear regression? Linear regression is a supervised learning algorithm used to predict continuous numerical values. It models the relationship between an input variable x and an output variable y by fitting a straight line which is expressed as y equal to mx plus b, where m is the slope and b is the intercept. The model learns by adjusting the slope and intercept to minimize the difference between predicted and actual values, typically using gradient descent. Alright. So, what do you understand by this, friends? What do you understand by linear regression? I will explain it to you. Linear regression is basically a supervised learning algorithm. I hope you are already familiar with the supervised and an unsupervised learning algorithm. So, linear regression is a supervised learning algorithm which is used to predict continuous numerical values. It predicts the values that are continuous in the nature, and it models the relationship between an input variable x and an output variable y by fitting a straight line expressed as y equal to mx plus b. You might already be familiar with this equation. So as you can see, y is a dependent variable here, and it's dependent on the value of x, whereas x is an independent variable, right? So here m is the slope and b is the intercept. Using this model, this basically helps in making the model learn by adjusting the slope and intercept to minimize the difference between predicted and actual values, which is done using a gradient descent. There is a mathematical formula behind it. You can go and look onto that formula, but right now we are more concerned regarding the theory and the algorithm part, so we will not go into the mathematical formula for now. So it has some features. Let's learn about those. It predicts continuous numeric outcomes, right? As I already told you, it assumes a linear relationship between input and output, right? Where y is a dependent variable and x is an independent variable, right? Finally, it uses gradient descent to optimize the line for minimal prediction error, right? So once you go to the formula, you will be able to figure out that it is basically minimizing the error. It chooses a line, it plots a line on the map, and using that line it finds out the mean of both values, the mean of x, the mean of y, and basically you get an output, and the output of this average of mean, and you use it to plot a straight line that passes through the meeting point, and that's how it tries to reduce the error, right? We don't have to go in a lot of mathematical part, but that was about it. So when to use linear regression? Linear regression is effective when the data shows a clear linear trend. It is simple, fast, and easy to interpret, making it suitable for baseline models and small data sets. However, it may not perform well if the relationship is nonlinear or when outliers are present. right? So what does this mean? This basically means that the model might not work in an optimal way if the relationship of the variables is a non-linear relationship, or when outliers are present. See, I already informed you what outliers are, right? So you already know about it. Finally, we will see some of the limitations. In this, it only models linear relationships. It is not able to perform on non-linear relationships. Then it is sensitive to outliers, as you already understood. And finally, it is not ideal for complex or highly non-linear data, which we already know. So that was all about linear regression. I hope you are able to understand. Thank you for watching.